So now I'd like to invite the next presenter, Vincent, to join me on the stage, and he'll be telling us about Agile semiconductor manufacturing. So thank you. Good luck.
Yeah. Good afternoon, everyone. My name is Vincent Barlier. I'm Commercial Director for Pragmatic Semiconductor. I take care of the foundry business. And today, we will be discussing semiconductor manufacturing, how we can bring a more agile way of manufacturing semiconductor, and how it can help to strengthen the industry resilience. So first of all, little introduction to Pragmatic Semiconductor as a company. So we are the world leader in ultra low-cost flexible chips, so integrated circuit. We are headquartered in Cambridge, UK, but we have our manufacturing site in the northeast of England, in Durham, near Newcastle. It's a growing company. Today we are around 300 people, but actively hiring more. We have a long list of investors and completed some successful funding round in the last 2 years. And what we make today, well, we make what I call a thin and flexible wafer. This is our product. So on this wafer, you have around 5,000 NFC chips, which are around 3 square millimeters. Each of the chips will have, in terms of complexity, around 1,000 logic gates. So it's a fully integrated circuit, which is made on a very thin substrate, polyimide. Is around 30 micron. It's very flexible, can be bent to reduce of curvature of a few millimeters, and it's overall very low cost, a fraction of the cost of a silicon wafer. So it can enable a lot of type of application around connecting product, adding some sort of sensing element, and also computing capabilities. So for the talk of today, I wanted to discuss the role and impact of semiconductor in digital transformation. So we all live a digital transformation. We have more and more objects that are connected today, and there will be even more. So between 2020 and 2030, there will be basically a doubling of number of connected objects, going to 30 billion in 2030. In order to gather information from those connected objects, you will need some sort of infrastructure. So the cloud system that we live today is not geared for that, because obviously too much data will have to be processed on central data center. So a way of addressing the problem is to do edge computing, where you will have more localized data center, which can help basically unloading the big data center. But another way of approaching the problem is to actually bring some computing power on the item itself. So if you do that, you basically simplify the information that has to be transferred to a data center, and you can process much more. On that relay, overall, on the ability of adding some sort of semiconductor technology into item level. So semiconductor will be key in the move to edge computing, but that also be key in our transition to net zero. So currently, we are on a trajectory where basically by 2030, we will have reduced our carbon emission by 7%, which is far away from the objective of Paris Agreement, which are 55%. And if you look at the study, you can say that 20% of carbon emission could be actually reduced by adopting IoT technology and all the digital transformation. And that can be enabled by semiconductor today. How can we help with this? So different challenges is this one look at our item level tracking can help in the way we consume product. Think about the packaging weight that we use, probably reflect on how many packaging you've been using in the last 3 days, for instance. So 200 kilograms of packaging waste that are consumed per person in the Western world. Look at food waste as well. 30% of all the fresh food that we actually produce are thrown away before even going onto the shelf. So they don't even eat the grocery store, they are thrown before. Think you can add actually some sort of recyclable packaging into that, but most of the